Welcome to an extraordinary journey, one that stretches your imagination and takes you to the farthest reaches of existence. Today, we'll travel to the very edge of the observable universe, and ask the ultimate question. Buckle up, the universe is bigger than you think. What is the observable universe? A timeline from the Big Bang to today. 13.8 billion years ago, the universe as we know it began with the Big Bang. Since then, light has been traveling through the expanding fabric of space, giving us a cosmic horizon, a sphere of everything we can possibly observe. This region is called the observable universe. It stretches out about 46.5 billion light-years in every direction, forming a sphere roughly 93 billion light-years wide. Now, wait, if the universe is 13.8 billion years old, how can anything be 46 billion light-years away? The answer: expansion. Space itself is expanding, stretching the distance between us and distant galaxies faster than the speed of light. That's why what we see now was actually emitted billions of years ago from galaxies that have since moved much farther away. What do we mean by edge? Different interpretations of the universe's edge. When we talk about the edge of the universe, we don't mean a physical wall or a boundary you can hit. There are a few different types of edges scientists discuss. The particle horizon, the limit of how far light has traveled since the Big Bang. The cosmic event horizon, the farthest point from which light will ever reach us. And the visual edge, the cosmic microwave background, the afterglow of the Big Bang. All of these are different kinds of limits, not barriers. Beyond them, space continues, but we just can't observe it yet. Would you like me to continue the script with the next sections? Let me know if you want it in one big piece or broken into parts. Great! Here's the continued script for your YouTube video. Journey to the edge of the universe. What lies beyond? We're picking up from where we left off. Shooting star: is there a real edge? A traveler approaches the edge of the known universe. Fade into abstract visuals of curved space. So, is there a real edge to the universe? A place where everything just stops? Surprisingly, the answer is, probably not. The observable universe has a boundary, but that's just a limit of what we can see. The universe itself might go on forever. In fact, current evidence suggests that the universe is flat, which, in cosmology, means it's likely infinite. But even if it's not infinite, it could be finite and unbounded. Imagine a 3D version of the surface of a sphere, or more precisely, a 3 torus, like a cosmic donut. If that's the case, you could theoretically travel far enough in one direction, and end up back where you started, without ever hitting an edge. That's wild, right? A universe that loops in on itself. What lies beyond the observable? Faint galaxies disappearing into darkness. Graphics show hypothetical unobservable regions. Beyond the edge of our observable universe lies the unobservable universe. It's the part of the cosmos that exists, but from which light hasn't had time to reach us yet. Think of it like this: we're inside a cosmic bubble. Beyond that bubble, the universe continues, possibly forever. Based on our best estimates, the actual universe could be hundreds, even trillions, of times larger than what we can observe. And according to the cosmological principle, it should look pretty much the same out there: galaxies, stars, dark matter, all stretching endlessly. But here's the catch: we will never see it. The light from those regions will never reach us, not even in the distant future. Those galaxies are moving away from us faster than light due to cosmic expansion. They're forever beyond our reach. Theories of the multiverse. Bubbles forming in a foam, each one a different universe. Some scientists believe that what lies beyond may be more than just distant galaxies. It could be other universes. This is the idea of the multiverse, a collection of multiple, perhaps infinite, universes, each with different physical laws. In some versions, like eternal inflation, our universe is just one bubble in a vast cosmic foam. In others, like quantum multiverse theories, every possibility is realized in a different branch of reality. While these ideas are still speculative, they could explain why our universe has the laws and constants it does. But as of now, we have no way to test them. They remain a fascinating possibility, sitting just on the edge of science and imagination. The shape of space. Let's go back to the shape of the universe for a moment. Is space flat, curved, or wrapped in on itself? Observations of the cosmic microwave background suggest that the universe is flat within 0.4% margin of error. But this doesn't tell us its full shape or extent. Some models predict a looping topology, where space connects back to itself in multiple dimensions. If true, we might one day spot repeated patterns in the sky, distant galaxies appearing in more than one place. But so far, we haven't seen this. The shape and size of the entire universe remain one of the biggest unsolved mysteries in cosmology. The future of the cosmic horizon. The edge of the observable universe isn't fixed. It's changing every second. As time goes on, light from farther and farther regions reaches us. But paradoxically, many galaxies are already disappearing. Because of dark energy, the universe's expansion is accelerating. In the distant future, tens of billions of years from now, most galaxies will have moved beyond our cosmic horizon. Future astronomers may see only the Milky Way and its neighbors. The rest of the universe will fade away. In that lonely future, knowledge of the Big Bang and the cosmos could be lost entirely. That's why studying the universe now is so important. Perfect. What it all means. Standing on a tiny planet in an ordinary galaxy, we've managed to map a universe that stretches billions of light years in every direction. We've discovered an edge, not of space itself, but of what we can currently know. Beyond it may lie trillions of galaxies, strange cosmic structures, even parallel universes. Or, it might be something entirely different. The truth is, we don't know what lies beyond the edge of the observable universe. And maybe, that's okay. Because the greatest part of science isn't just in the answers, it's in the questions that lead us there. And as long as we keep asking, keep wondering, and keep looking up, we'll keep moving closer to the heart of reality itself. If you enjoyed this journey to the farthest frontiers of space, there's so much more waiting. Here on Core of Space, we explore black holes, time travel, alien worlds, and the deepest mysteries of the cosmos, every single week. So if you're passionate about the universe, and love going deep into science and wonder, thumbs up and give this video a like if it expanded your mind. Until next time, stay curious. The universe is vast, but the journey begins at the core. Backhand index pointing right. Subscribe to Core of Space. Bell, hit the notification bell.